Hello and welcome. This is the quiz solutions for quiz 1. What is the chemical symbol for potassium? That's K. Kind of a trick question. You might think it's P, but that's phosphorus. Write the number here in scientific notation. So that's going to 3.405 times 10 to whatever the power needs to be. It's going to be negative 1, 2, let me zoom in a touch here. So that'll be minus 1, 2, 3, 4, 5 times 10 to the minus 5. What is the density of mercury is 13.6 grams per milliliter. What is the volume of 100 grams of mercury? So the number of milliliters is a unit of volume, 100 grams of mercury, and then what we want to do is 13.6 grams per ml. So 100 grams, 13.6 grams per milliliter. We're using our conversion factor of density with scientific notation, and we just want the grams to cancel in the denominator and numerator here. And if we carry out that arithmetic, we would get that particular quantity is, I'm doing the math, 7.35 milliliters. So mercury is pretty dense. Okay, so given 1 inch is 2.54 centimeters exactly, and 1 foot is 12 inches, how many cubic feet are in 1.55 times 10 to the 5 cubic centimeters? Okay, this actually is a little bit harder than what it might look to carry out this conversion, because what we need to do here is start with what we have given, 1.55 times 10 to the 5 cubic centimeters. And we can use our centimeter to inch conversion. And I'm just going to write out the conversions that were given here and how we can use them. And we can plug the numbers in 1 second. So there's 2.54 centimeters in 1 inch, and then there's 12 inches in 1 foot. The information was given in the problem. Not every student in the class is from the US, and if you're from overseas, you may not be so aware of the metric to non-metric conversions. But anyways, those aren't the only conversions we need to make in this problem. We actually need to cube the conversion factors. So if you had 1 cubic inch, so if you had 1 inch by 1 inch by 1 inch in terms of a cube, where you had an inch on each side, if an inch is 2.54 centimeters, then that cube would be 2.54 centimeters cubed for its volume in centimeters compared to inches. If you had 1 inch by 1 inch by 1 inch, that would be 2.54 by 2.54 by 2.54 centimeters. So we need to cube our entire conversion factors. That means we need to take 1 inch cubed, so that's just 1 still, inch cubed, 2.54 cubed, centimeters cubed. And so then we need to take 1 foot cubed, 12 cubed, inches cubed. And then when we carry out the arithmetic, we need to make sure we do 1.55 e to the 5 divide by 2.54 caret 3 divide by 12 caret 3. So let me do that math maybe with you as you guys are doing this too. 1.55 times 10 to the 5 divide by 2.54 cubed, and then divide by 12. And this works out to be 5.47. cubic feet. Okay, so our next question asks, a 5.5 gram sample of a substance contains only carbon and oxygen. Carbon makes up 35% of the mass of the substance, while the rest is made of oxygen. Which of the expressions demonstrates a mathematical procedure to determine the mass of oxygen in the sample using the proper order of operations? Okay, so the sample is 35% carbon, so that would mean that 100% minus 35, so that would be 65%, is made up of oxygen. Okay, and so we also have a 5.5 gram sample. Of this mass of our sample, 65% of that mass is due to the oxygen. So we want to determine a mathematical representation for solving and determining the percentage of that sample, and really the mass of that sample that is oxygen. So what we want to do is take the 100% of our sample, 35% of which is carbon, subtract that from the 100%. We want to multiply that by 5.5 grams, and then that will lead to the mass of the sample that is only made up of the oxygen. And so you can see some of these are mathematical steps are not going to achieve the correct answer because they have kind of the parentheses in the wrong spot. So this here doesn't work, and it also sometimes has like an extra 100 in it. So if you were to do part A, like imagine just trying to work this out. Like if we were to take 100 minus 35 divided by 100 times 5.5, that gives us 98 grams? That doesn't make any sense. So that wouldn't lead to the right answer. So A is not a correct answer. B, 100 minus 35 divide by 100, then times 5.5. See, that's probably going to get us closer to the answer because our answer is not 65 times 5.5. It's 0.65 times 5.5 grams would achieve the correct answer. So we need to take our difference, 65%, and then divide by that 100% to go back to the fraction as 0.65 of the sample is oxygen, 0.35 as a fraction of the sample is due to the carbon. And so 0.65 times 5.5 will lead to the correct answer. And so then taking 100 minus 35 dividing by 100 would achieve the correct answer. And we can double check that too. Do 100 minus 35, then hit enter because that's in parentheses, then divide by 100, and then multiply by 5.5. That gives us about 3.6 grams. That would be the mass of the sample that's due to the oxygen. Now notice part C, we miss the operation by not putting a parenthesis in here. So if we were just do 100 minus 35, then divide by 100, just the 35, and then multiply by 5.5, that gives us the 98 answer again. Same answer that we actually got in part A as well. Now this is not correct just because our order of operations is not correct here. We need to be doing this 100 minus 35, then divide by 100, then multiply by 5.5 grams. And then part D, let's see if that one works out as well. If we do 100 minus 35 divide by 100, making the same mistake that we made earlier, multiply by that by 5.5, we get an answer that's way far off here. This is 548, nowhere close to the right answer here. So wrong answers for A, B, and D. Correct answer would be B. So a weird question, but this is just trying to get us to think a little bit outside the box of order of operations. Where do we put parentheses, and then how do we use that to help us solve a particular problem? Okay, so number 5 above for our next question. What is the actual mass of oxygen in the sample? Well, you can carry out the order of operations in part B, or just remind ourselves that 0.65 of the sample is oxygen. So if we say 65%, the fraction of the sample that's oxygen is 0.65, and then times 5.5 yields that answer of about 3.575, rounding to 2 sig figs would be 3.6 grams.